Hello and welcome to our Trustpoint Tech Intro. My name is Florian Handke from Campus Schwarzwald, and I'm here today with Christian Schwinne from Hochschule Hamm-Lippstadt and Alexander Harig, also from Campus Schwarzwald. Hi.
Hey.
Hey.
We're giving a quick introduction to Trustpoints and the features which are available. But before we start, tell us a little bit about yourself. So, Alex, who are you and what have you been working on recently?
Yeah, sure. So I'm Alex. I'm working at Campus Schwarzwald as a software engineer and currently focusing on the CMP protocol. So basically a certificate management protocol, which offers several different methods for certificate requests, certificate revocation, and similar. And I'm part of the Trustpoint project as a whole since 2023. Yeah.
Thanks. Christian.
Awesome. I'm Christian. I am a research associate at the Hamm-Lippstadt University of Applied Sciences, and I'm also working in the Trustpoint project since 2023. And I'm doing also various software engineering tasks. And lately, I've been adding the auto-generated PKI, which makes it easy to test out our Trustpoint, even when you don't yet have an external PKI structure deployed to integrate it with.
Nice. So we start right away with Alex, who will guide us through the wizard and then CMP, and Christian will then tell us about manual certificate retrieval and ESD capabilities in Trustpoint. So, Alex, the stage is yours.
Sure, thanks. So we'll basically start setting the Trustpoint up and injecting some demo data so we can easily test some features or try it out. What we currently have, we have two Docker containers running, one containing the Trustpoint itself and one containing a Postgres database. So you can either get them from Docker Hub, or you can build them yourself from the GitHub repository, and everything is described in detail in the documentation. So we already prepared those containers and just went or accessed the localhost on HTTP. So the first step we have to take is to generate or insert a TLS server certificate to use for the Trustpoint. And in this case, we are offering to generate a self-signed TLS server certificate, which we will do now. So what you have to consider, if you're just running on localhost on your local machine, you can just keep the preset data for localhost. If you are running it on the different machine and want to access it under a different IP address or domain name, you can just add it here. This will be included in the TLS server certificate later on. So we'll just generate it. So we can now basically download the Trust Store for the certificate and import it into our browser so we don't get any error messages. For the demo right now, we will just accept it and will not include it into our browser. So we will apply the TLS configurations. So since we didn't import anything in the browser itself, we will get a warning that it's not secure. That is expected. We can then click on Advanced and proceed to localhost unsafe. One note, there may be a pop-up asking you for a client certificate. You have to cancel that one because we do not expect a client certificate at the moment. This is basically used for PKI protocols and not for the graphical user interface. So if you select one, you may not be able to access any further pages. So it's important to cancel it basically. So now we have the option to insert some demo data. We will continue with the demo data just to create some devices, some issuing CAs, so we can easily explain all the features we have currently. So this will take a moment. Right. And we will create a admin user. Oh. And we log in into the Trustpoint. So now we are basically on the dashboard, which will just give you a summary and overview of the current state of the Trustpoint and all what's everything what's going on. And usually if you don't use any demo data, this will basically be empty, of course, but now we already created some entities like devices and issuing CAs. So we will start looking at the issuing CAs. So basically about the concept, issuing CAs is an abstraction of an entity that is able to issue and sign new certificates. You will have different options on how to create those. This could be an issuing CA that is a private and public key pair, and a certificate chain that is locally issuing new certificates on the Trustpoint for the devices. Currently, we support importing PKCS12 files, basically containing those files or information. And that will then be able to issue the device certificates. In the future, what we are planning is we will also offer a way to request issuing CA certificates from an external PKI using common protocols. But we will also allow we will allow the Trustpoint to act as a so-called registration authority. Basically, it will just check requests for certificates and forward them to the external PKI, and the external PKI will then sign certificate or issue certificates. Right, but currently we have only local ones. So basically we have the key pair on the Trustpoint and are able to locally issue new certificates. And we just created a few different issuing CAs with different signature suits, basically the combination of the asymmetric encryption algorithm and the hash algorithm. Right. And then on top of the issuing CA abstractions, we have so-called domains. So every domain will basically exactly have one issuing CA. That means that inside one domain, all device certificates issued will be issued by one specific issuing CA. Basically, if you consider you have several different groups of devices and you want to be, do not want to allow the devices from different groups to talk to each other, you can split them up into different domains. But you can, of course, onboard a device into multiple domains later on. So, for example, for a gateway in between. Right. And that's basically all there is on top. So we have issuing CAs, which is an abstraction of the CA itself, which issues certificates, and domains, basically groupings of or groups of devices. Right, and then we have the devices itself. We can choose to manually create devices and provide them with certificates, but there is also a way to automatically create devices just by requesting specific certificates, which we will see later on. What's maybe important to distinguish here, there are two basic ways of providing certificates for devices. One is called onboarding, or that uses onboarding. So if a device is able to speak or to provide publicly infrastructure protocols, so it can properly request new certificates and has network access and so on, then we can provide a device with a so-called domain credential, which will also only be used for authentication, basically, for requesting further certificates, which then will be called or are called application certificates. And of course, if devices are not capable of that, maybe they are not on the network also, we can just create certificates manually and download them and manually provide the device with the certificates, maybe using a USB stick. And I guess that manual download is the most simple one. So we will start with that one. And I guess I can give that to Christian. He will present the manual download part.
Yes, thank you very much, Alex. So first of all, I will start by showing the manual onboarding. For that, I can just add a new device to the Trustpoint. I'm calling this manual test right now and just giving it a test serial number also. And now I can choose either whether I want to use this as a domain credential or not, and just issue an application credential directly. In this case, for the manual download, it is not currently supported to use it as a domain credential. It's just for directly obtaining application certificates, basically. So now I can create this device. And now I can go manage, and this is the certificate lifecycle management overview for this device, where I can see all the credentials that have been issued to the device and manage them. For example, I can revoke them. And now I can issue a new application credential to the device. For example, if I want to use it as a TLS server, I can issue a new TLS server credential, and then I can also customize the common name and the IP addresses that are to be included in this certificate. And if I'm done with that, I can just issue the application credential and it will be issued. And now I have the option to download it right in the web interface here. It is a credential always includes both the certificate and also the private key. If I so it needs to be encrypted to be safe, so I can set a password here for the download, and then I have the choice either to download it as a separate PAM-file, so the certificate and the key will be separate, or like a PKCS12 file where that is combined. So that depends on the use case and the application and the actual device, what you would prefer here. You can also download multiple of them. So right now I can download this credential. Now I can, for example, put it on a USB stick and go with that to my device and install the credential to use it as a TLS server. There's also an alternative way we have implemented to make this a little easier. I can go to download on device browser, and this will generate me a one-time password, which I can then use. And now I can go over to my device, assuming it has a standard web server, and open this device's browser URL, which is always the same. And then I can easily enter this one-time password that I obtained from the admin user interface and click download, and that will allow me to also download the credentials directly on the device. For example, now I can try it again and download the separate PAM files instead. And there we have our download. That's basically it for the manual certificates. And now that we have several automated ways. The first of which is EST. So now I will show you how to obtain a credential using EST. So I'm calling this EST test device, and the serial number will be EST42. And now we can also select a domain where we want to onboard the device. For example, I will select Phoenix Contact here. And I also have the choice whether I want to use the certificate obtained via EST for onboarding. So if I want to request a domain credential, or if I want to request just a normal application certificate. In this case, I will want to request a domain credential so I can use it to request further application certificates in the future. I will set EST with username and password as my onboarding method. And now if I create this device, it will give me a step-by-step guide and all the information I need to onboard this device via EST. Now in this case, you can see there's still a banner over here that tells me that in the domain settings, we currently do not have EST username and password enabled. So we just go to PKI domains, and then for the domain we want to add the EST device to, we can configure it and just activate it here so that username and password is allowed to use for onboarding. And now I can go ahead and go back to the commands here. This is help issue new domain credentials. Here you can always see how to issue new domain credentials. And the first step is to generate a key pair. So we will go to our device, to the terminal, and then we can generate the key pair. Okay, this is generating an elliptic curve key now, and then I can go ahead and create a certificate signing request, which is what will be sent to the Trustpoint in order to successfully issue a credential so that it knows which fields like to include, like which common name and so. So now we have the certificate signing request, and now comes the important command, which is to just send a request to the server in order to actually issue the credential and send it to our device. The big advantage of using EST over manual download is that the key pair is generated right on the device, so it never really has to leave the device, which is a major security gain as compared to generating it on the Trustpoint, because then it will remain in the database and could be stolen more easily. So if possible, we always recommend using EST or CMP for onboarding. And now you can see, now I've obtained a certificate. If I now go ahead and try to view it now you can see here we have a certificate. This is like a binary format, therefore it looks weird, but you can see like it has a certificate name, and here you can see the domain where it is issued. So basically that is the EST onboarding that we offer for a semi-automatic certificate enrollment. So that will be it. And now I'm handing back to Alex, and you want to show us onboarding using the CMP protocol.
Yeah, thanks. Right. So CMP is basically an alternative to the EST protocol. It's, I guess, more modern, but also more complex, and there are far less implementations up to now. However, OpenSSL, a very common crypto library, offers at least a basic CMP client which one can use. And there are several modes, I would say, how you could use CMP. And we will basically start by showing CMP used by a shared secret and directly issuing application certificates. So basically, we are not doing any onboarding here, but we can directly get, for example, TLS client or TLS server certificates. And all we have to do is click on the help page. It's basically the same you would see when you're creating a new device with this exact PKI protocol. And this is basically working pretty much the same as with EST. Basically, we just have to copy the commands. So we'll first start by generating a key pair. In this case, So if you're wondering why we are using RSA with a 4K sized key, it's basically the signature suit or the key type and length of the issuing CA is implicitly enforcing which key type and length we have to use for the device keys, because we do not want to change them up in the OT environment, because we're never sure if a device is able to handle any other key types. So we generated the key, and then we can directly use OpenSSL and CMP to request a TLS client certificate. In this case, we can see in the command here, this is basically the shared secret. It's generated by the Trustpoint, and both sides, due to the fact that I'm copying the command and using it on the client, both sides know the shared secret, and they will derive a key, a symmetric key, which protects the CMP message. So we can just execute it. And we got the client certificate. Of course, we can't see much this way, so I'll just do it for this one and try to encode it. Oh. So what we can see here, we got the common name we have chosen. The pseudonym is basically set by the Trustpoint. It's basically describing what kind of certificate it is. It also gives the domain component, or the domain we are using, also set by the Trustpoint. The serial number of the device, which is either given on creation of the device or implicitly by a request if a device is implicitly created. We will look at that later. And of course, the issuing CA we were using in the Trustpoint. Okay. So currently we are offering some preset templates for certificates, for example, for TLS client and TLS server certificate, but we will also include basically a generic template where you can completely customize your certificates. But in most cases, it's probably sufficient to just use the templates, especially because you can then be sure that you're using the correct certificate extensions or details in the certificates that have to be set for a TLS client or TLS server certificate. And there are some parameters you can always mutate. For example, the common name can be completely custom. Maybe you would rather like to choose anything more verbose and for your use case. And you can also customize the validity, of course. It's always nice to have short lifetimes of the certificates, but it might not be practically usable in the real world. So you could also set it to an arbitrary amount. And basically the same for TLS server certificate. And you can, of course, set the subject alternative names, that is the domain names, IP addresses, and so on, for which this TLS server certificate will be used. Okay. So then you can see we have the domain credential available on the device, or not the domain credential, the application credential. It's a TLS client certificate. And if we click on download, we have to remember we can't download the credential itself because we do not have the key pair available on the Trustpoint. That one was created on the device. We can only download the certificate itself and the certificate chains. Okay. So, and the next one I would like to look at is using a domain credential. I will not be executing this one, but just have a quick look. So basically, it is also using a shared secret, but this time not to get application credentials and certificates, but the domain credential, which is then used for authentication. That will basically use the exact same command or command structure, also with a shared secret. All right, I actually have to execute it quickly. To get access to the help page for the application certificates. So we can see we now have created the domain credential. So the device is in possession of the domain credential, and we can now click on the application credentials help. And we are now using a credential that is a certificate and a key to authenticate against the Trustpoint, which we can see here. So it's not a shared secret anymore, but the certificate and key. And what we now also need is the certificate of the key pair that is signing the CMP response message. Otherwise, we couldn't check if we got a valid and genuine CMP message back. So what we have to do here is saving the issuing CA file in a PEM file, generating the key again, and then just executing this command, which is again basically the same, just instead of the shared secret, certificate and key, and the issuing CR certificate for verification. Right. And then we'll have a look at the more sophisticated way, I guess. So an IDEF ID, so initial device identifier, is basically a certificate that is imprinted on the device by the manufacturer. So that's basically the way we can verify that the device is genuine. And we could also create a device. That's maybe a bit better. So, right. So we are saying here that we want to onboard is using a domain credential. So the device will get a domain credential. We will, and we want to use an IDEF ID. That is, we expect the device to have such a certificate. And what we have to do now is to select the trust store. Basically, that will be used to verify the device identity or the certificate on the device. In this case, I'll just select the 2K one, RSA, and I'll create the device. Right. And then we can just, so I prepared some IDEF IDs, basically the certificate that would be present on the device. And I'll just get one. This is serial number. So this is basically the IDEF ID we will use. And then we will also get the issuing CR certificate to verify the CMP response message. So I'll just use the command line, but you can for sure also just download it as a file directly. Oh. So you now have the IDEF ID and the issuing CR cert. We will then generate a domain credential key. Right. So what we now have to do, we have a P12 file that is a PKCS12 format, and OpenSSL itself and the CMP command do not directly support the P12 files, so we basically have to take them apart, which these commands are for. I'll just copy and paste them for now. Basically, we will now get the key and the certificate and certificate chain in separate files, which are all contained in the P12 file. And then we can already basically execute the CMP command. So again, we are using the IDEF ID for authentication and the issuing CR cert for verification of the CMP response message. Okay. And now we got the new domain credential. I will once again decode it. So we can already see the common name. It's a Trustpoint domain credential. It's basically set by us because the certificate is purely used for authentication against the Trustpoint. There is just no need to be able to customize this one. We can also see the issuing CA used, the domain for which it is used. Very important is the serial number. So, and that's basically it. The further steps, so basically requesting application certificates now is exactly the same as for the previous CMP mode. And I can just always use these commands. And if I want to, I can modify some fields, validity and the common name. One more interesting use case maybe is if you have several devices from one manufacturer, but you do not yet know the serial numbers, or you do not want to manually add all of those devices, you can basically select a domain in which you would like to onboard those devices. Click on config and go to the section Dev ID registration patterns. What this basically allows is it configures a trust store, and you can pass it a regex pattern for serial numbers, and it will then accept all domain credential requests coming in from a device with those IDEF IDs, and it will then implicitly create devices. So in this case, we already, the demo data already included one Dev ID registration. So we can click here on help. And basically it works exactly the same as the previous example, just that we didn't create a device beforehand. So if I do this again, IDEF ID. So it was 2K, and we will now use IDEF ID with a different serial number, 3 to 1. We had 1 to 3 before. So it's the same, should be the same. Just to be sure, I'll just remove all of it. So I'll just get the issuing CA again. There it is. I'll generate a key again. Extract the data from the PKCS12 file. Oh, got it on the wrong side here. Maybe I could do it this way. Okay. And then I can just execute it. Basically, it's the same request for domain credential as we did before. And we got a certificate. And what's interesting now is that when we click on devices, we can see here that the device basically was implicitly created with the new serial number 321. And the device name, which is displayed here, is basically the common name and the certificate subject. And we can just now continue to get our application credentials and certificates like for TLS, OPC UA, and similar. Right. And that's basically it. So manual downloads or manual certificate issuance, EST issuance, and using CMP. Right. And I guess I can pass it on to Christian again.
Thank you, Alex. And now I will also quickly demonstrate another aspect of Trustpoint, which is our auto-generated PKI, which makes it easier to test Trustpoint. So for that, we have the concept of security levels in a Trustpoint. These are supposed to be aligned with the ISO 62443 standards, so which define 4 distinct security levels from security level 1 to security level 4. And we basically mapped it to a basic, medium, high, and highest security level. And this auto-generated PKI is strictly only intended for testing purposes, so it is only available in the lowest basic security level. So you can see if I try to set a security level to medium, then it will disable this auto-generated PKI option because it's no longer available. But on the most basic security level for testing, we can enable the auto-generated PKI. And if we do so, this will generate a complete PKI hierarchy. So it will generate root certificate authority with the selected algorithm, and it will also generate an intermediate CA, which we are using to actually issue the certificates. And it also, for convenience, it also adds a custom domain, Autogen PKI, which is then used to issue certificates in the auto-generated PKI. And now I can just use it as before to generate new devices. Then I just have to select the Autogen PKI domain here. And for example, I can just generate a manual download device and then, just as before, easily issue new credentials with the auto-generated PKI. And this makes it easier for testing because normally if you don't import or demo data, you have to add the issuing CA yourself. And to get these issuing CA files, you will need to have an external PKI structure, for example, EGBCA. If you don't have that yet and just want to test out the Trustpoint, whether it fits your use case, then we recommend using the auto-generated PKI because it allows you to get started easily. And another nice feature in the Trustpoint we have right now is the logging feature, where you can, within the web interface, you can view the log files and see if any errors happen or if anything abnormal is going on with the Trustpoint. For example, here you can see right now it generated a log message that the auto-generated PKI has been enabled. This is just so that for auditing purposes, it's really helpful to have this functionality. So basically, this concludes our little overview of the Trustpoint as of right now. And yeah, I'm happy you watched along, and this was my part.
Nice. Thanks for presenting Trustpoint and giving insights to the status quo, what we're doing. So right now we're in beta state and actively working on to get Trustpoint. I think we got some technical issues.
Great that they are happening at the end, better than before.
You're back now.
Okay, so before we get into more trouble, thanks for presenting, and there is more to come.
Thank you.
Also, thanks. I think again.
Goodbye.